First, download the template file that we're going to use in Table Plus. When you save the file, be sure that you replace the first name and last name. Then open up Table Plus and connect to your LME Build sales order database. Looks like today GitHub is experiencing service degradation, so if you can't download the file through the link, go to Brightspace. Under the SQL templates module, you'll find a transactions and triggers SQL file that you can download. Okay, so switch out your first name, last name. Save it as a .sql file. So make sure it says .sql here. And we'll connect to Table Plus Sales Order Database. And then you can open up that file. Today we're going to talk about transactions, which allows us to run multiple SQL statements and ensure that all of the SQL statements execute. And then we're going to talk about triggers, which will give us the ability to execute another SQL statement once a modification to data has been made. Transactions are typically a group of SQL statements, but you can run a transaction with just one single SQL statement. To MySQL or to any SQL server, if you're running a transaction, it looks like that group of SQL statements are performing as a single unit. So you have to execute all of the statements successfully in order for the changes to be made. If one of the SQL statements fails, then the entire transaction fails. So for any previous updates that were made before the error, those changes are rolled back. So what is the benefit of transactions? Well, it ensures that if you're making changes, if let's say the server crashes or there was a bug in a SQL statement, it maintains the data's integrity. So systems will crash, hard drives will crash, networks will go down, data centers will go down. Things like even GitHub, how they're slow to respond if there's network connection issues. Transactions will make sure that this whole chunk of SQL statements do execute and nothing is left incomplete. If there's a lot of traffic on the database, it can lock the table. So let's say if there's 100 concurrent connections and the queries are slow to run, and so requests to the database are timing out, and a transaction will prevent errors that were produced because of table locks or timeouts. When you execute a SQL statement and add that semicolon, the commands are set to auto commit. So once you hit enter after that semicolon, the changes are submitted to the database. So if you're doing an insert, update, or delete, those changes automatically are committed to the database. There are three main commands that are associated with transactions. The first one is the start transaction. Anything that follows a start transaction statement means that, okay, this SQL treat it as a single work unit until we say the transaction ends. And then by setting the start transaction, it disables auto commit. So if you run SQL statements after this, let's say an insert, an update, or delete, and hit enter after the semicolon, it won't send those changes to the database. It will only send those changes if you then type out commit. Okay, you have to submit a commit command in order to save the changes to the database. But if you want to roll back any changes because you encountered an error, you can, instead of running commit, you can say rollback explicitly. So this will revert any sort of changes that you made with an update, delete, or insert back to the previous state. Okay. So it won't commit any of those changes if you issue a rollback. And it'll only issue the rollback up until when you said start transaction. All of the SQL statements between rollback and start transaction will be reverted. Before we can use transactions, we have to change all of our tables in the sales order database to the InnoDB storage engine. Because right now, it's in the MyISAM storage engine format. That's the default storage engine format for MySQL 5.7, and that's a really old version. And that's why in MySQL 8.0, the default storage engine is InnoDB. So with InnoDB, it supports foreign keys. That's why we had to modify those tables early on in the semester in order to add our foreign keys. And also, InnoDB supports transactions. So we have to switch all of our tables in this database to InnoDB. If you want to confirm a table storage engine type, you can run this query. So we're going to first use the categories table in our example. So let's confirm its storage engine type with show table status where name equals categories. Categories is the name of the table in the sales orders database. It's showing MyISAM. And this is going to be the same for the rest of the tables. So we're going to have to change this to InnoDB. There's a default database in MySQL called information schema. And in this database stores all the information about the tables, views, columns, and procedures in the database. So anything you want to know about it, number of columns, the storage engine type, it's in this database. So we're going to look around in this database first because we're going to use this database to help us make these changes to the storage engine. There's a table called tables in the information schema database that gives us information about all of the tables across all the databases in our account. So let's see what happens when we select all columns from information schema, the name of the database, dot tables, and tables being the table name. Table schema is the name of the database. Let's scroll down until we see a database that we use. So let's say, look, here's a sales orders database. And here's the categories table, and it's showing it's a MyISAM type. It keeps also statistics on the tables, like the number of rows, the average row length, the length of the data, and there's a lot of other information here. When it was created, last time it was updated. So we're going to use this data to say, okay, give us the tables that are MyISAM for the sales orders database, and we're going to use a string function to give us the alter table command to switch from MyISAM to InnoDB. So let's build up to that query. So let's first select the table name from the tables where engine equals, actually instead of InnoDB should be MyISAM, and table schema equals your sales orders database. I know in the slide it said InnoDB, but it should be MyISAM because we're looking for tables that are currently set to MyISAM. And we only want to change it for our sales order database. Oops. Select table name from information schema. Oh, I forgot the and statement here. All right, so these are all our tables from the sales order database that have a MyISAM storage engine. Now that we can get the table names for the tables that are still in MyISAM format, we're going to use a string function that will give us the SQL commands to make these modifications. So we're going to use concat, and the command is alter table, the table name, and then engine equals inodb. So this is the command that we want to print out. So what we're going to do is replace out this table name by continuing to run this select. So in our previous SQL statement, we just did select table name. Now we're going to use that information and put it into a string that will give us the command to switch the table to inodb. Run this command and it will give you all of the commands. We're going to copy and paste that later. Alter table is the first part of the command, and we're going to concatenate it. Make sure to add a space here with the name of the table, and then closing it out with engine equals inodb. That will set it to the inodb storage engine type. And because this is a SQL statement we're going to run, we have to end it with a semicolon. That creates the string, and then the rest of the query we can copy from our previous statement. In the results, these are the commands that we're going to run. Instead of typing this out individually, we use this statement to conveniently output all of the commands. So we're going to say alter table categories engine equals inodb. We're going to run all of this. You can select it all, then copy, and then paste all of the commands, and we can run all of these commands at once. Programmers are known to be lazy, so this is an example of being lazy. Instead of typing it out, it just doesn't feel right to type out each command. Programmers try to think of ways to, how can I automate this? Because I know I'm doing something repetitive, so there must be a way to make it a little bit more efficient. So we did that by running this command. So always think of that, not just in SQL, but in other programming language. If you're doing something repetitive, maybe it's more efficient to code something up quickly. And the more you do this, the faster you'll get at it, because this is a common sort of table maintenance that you'll be running. Go ahead and run it. And it shows all of the status for each table, depending on the number of rows in each table. Let's confirm for the categories table to see if it's been switched from MyISAM to inodb. We'll do show table status where name equals categories. It shows now it's an inodb engine. We can now get into our first example. We're just going to do a simple insert into the categories table. We're going to set that new category to food. So before the insert, we have to run start transaction. Let's type that out so we don't forget. Start transaction. And excuse the background noise. My neighbors decided to take on construction projects during this quarantine. Okay. Make sure you execute this statement, so start transaction. And now within this connection or session, any subsequent queries will not be committed to the database until we say commit. So if you run an insert, update, or delete, it will not be committed to the database. Type out the insert statement into the categories table. We'll set category description to food. So run this statement. But the one thing is, after you run it and don't type out commit yet, query the categories table in another session. So what we're going to have to do is create a separate connection to the database. This will be a different window to Table Plus. So you could do connection, new, let's hit cancel from here, then connect to sales orders database. So if I select on the categories table, we don't see the food category. But because this is a current session, it can see it from this session. It can see the insert. If we just select from categories where category description equals food, it should show it in here. Okay, it shows that it was inserted in here, but because we haven't committed it, other connections to the database can't see it yet. So if I run this SQL statement over here in this separate session, the separate connection, it does not see the food category. So to save the new category, you have to add a commit. So make sure you add the commit in that current session where you started the transaction. Now if you run commit and then check in our separate connection, we should see the new food category. And there we see it. And it should still exist over here. To further illustrate what's happening with a transaction, we're going to try to update that recently inserted food category to drinks. But we don't really want to update it. We'll try to update it, but we're going to roll it back. And we'll see what happens with the rollback command. So we have to start the transaction again. Now any updates that we run after this statement will not be committed to the database. So other new connections cannot see that update. So now try to run that update. We're going to simply replace food with drinks. Actually, as good practice, always write your where statement whenever you're making modifications to a table. So in your update or delete statements, always write the where statement first. And generally you'd run a select first before this, but we already did that in the previous example. We'd run a select just to verify what you're updating. Set category description equals drinks. Okay, so let's see if it can see it in this session, which it should. Okay, so it was updated to drinks already because it no longer can find the food category. But let's copy this query and go into our other connection here and rerun that. So it's in that separate connection because it has not been committed in this transaction, it's still seeing the food category. But we've decided, let's say we don't want to update it to drinks. Or let's say some sort of error happened, so we'll run a rollback. Okay, so once it's rolled back, this update no longer holds. So if I did a select in this window with the transaction, we should still see the food category. Whereas when we previously ran it in this window in this session, it was no longer seen. Okay, so let's confirm in the other session, it's still there too. Okay, so the rollback reverts any sort of changes that were made up until the start transaction. For our next example, we're going to repurpose the insert statements we used for the variables and prepared statements lecture. Okay, we're going to insert a new product again, or a new bike. So we're just going to just copy and paste that code, but we're going to convert it into a transaction. You recall there are two different inserts that were happening. There was an insert into the products table, and then there was also an insert into the product vendors table. An example scenario would be if you're running all of those statements and let's say your computer connection or the server connection died because of a network issue or a hardware issue, those statements would not be committed if it was part of a transaction. Okay, so let's say if you ran the insert, it went through, but the connection cut out, it would not proceed and insert into the product vendors table. So that's what we're going to do in this example. We're just going to convert that code into a transaction because all that code is going to act as a single unit and not individual statements like how we were running it before. We were running it one statement at a time. It's just going to run as one full code block. To differentiate the product names when we spot check our results, we're going to insert the product name as Huffy Mountain Bike. But everything else will stay the same. So all of the variables that we're setting, that can remain the same. So all we have to do is add a start transaction at the very beginning and then add a commit at the end. So I'm going to go to my last example from the previous lecture. And one thing I want to point out, and this was my fault for not spot checking my own work. In this statement here, I had it as a lowercase v before, but that table does not exist. But we ran the query and it did not give an error back. So I should have been spot checking. So it should be a capital V in order for us to get the vendor ID. Copy, and we're going to copy all of this code and paste it into table plus. So go all the way to the top, and we want to form this as part of a transaction. All the statements after this start transaction will not be committed until we say commit. We'll just run this all at once. But it's possible if my internet connection died on my laptop right now, and if the insert into the product table worked, but right after that insert, the connection went out, it would not insert into the product vendors table. Okay, so I'm going to run all of these statements at once. And let me double check that it's successfully inserted into both tables. So I should be spot checking my work. Let's double check in the products table. Goes Huffy mountain bike. Great, it's It's in there now as product ID 46, product number 46. So then you take that value and query it from the product vendors table. Okay, good. So it can confirm both inserts successfully went through. But as this set of transactions was running, if I were to go into my other session, I would not see the insert into the product table and into the product vendors table until the commit was executed. So we're going to move on to triggers now. And this is another relatively new feature to MySQL. It's only been there for the past few years, but it's a handy feature, and you'll see why. So what it is, it's a stored program that you're going to create that runs on the server. Okay, you're going to code it, and it's going to be saved directly on the MySQL server. It's not code that runs in, say, Table Plus or a Python script. It runs on the server. So it only executes whenever there's some sort of modification to a table. If there's an insert, update, or delete against a table that you name, the trigger will run. Okay. So the insert, update, or delete will really trigger the trigger. So when do you use these triggers? Well, you want to maintain data integrity. If you want to ensure that certain tables have certain values set or have certain rows associated to those new modifications. You can enforce certain business rules. The triggers are good if you want to maintain some assumptions that are easily forgotten. Okay. So you can enforce these business rules without having to remember to run this extra code in your application or in your BI tools. You can just put it on the database and it'll take care of these rules for you. If you want to validate data, so if you insert into a table and it has a certain column format, you can ensure that column format is consistent in another table. And this is one use case that I use a lot is if we want to update denormalized data. So denormalized data is primarily you could think of it as duplicated data. So it's not normalized until say second or third normal form. So if you have to keep track of certain counts or sums in a table, you can automatically set those values when, let's say, an insert happens. So if you insert a new order and you want to keep track of the number of orders in another table, you can increment that order count with a trigger. And then also for audit logs, I use this a lot also, especially with Sarbanes-Oxley for auditing purposes. You need to keep a paper trail of any sort of modification made to the data, and triggers can help you do that. So when we were being audited and we had to make sure that we conform to certain compliance rules, we had to show in our database, okay, we're keeping track of how the data is changing. And we did that with triggers. So whenever, let's say, a new insert was made or if a certain value was changed, we can keep track of the old and new values and who changed it and when it was changed, all through triggers. There are some downsides to triggers. I know I just gave a load of praise to triggers, but the two main ones is it can complicate application debugging because you can be running a statement and then data is changing and you have no idea why if you're not completely aware of the triggers or you forgot about the triggers. So if you don't educate your users or give them proper documentation about certain commands, especially relating to updates, inserts, or deletes, they can get really confused because they'll think, I made this change here, but this other table is changing and not as I would expect. So you have to make sure that whenever you're coding your SQL, think of all the triggers associated to that table you're dealing with, okay? Because that can change the logic of what you're trying to accomplish. Then it could also increase database load. So if you're doing a lot of transactions, a lot of inserts or deletes, and then it's then setting off another cascade of SQL statements in these triggers, it can create an increase in database load. Whenever you make changes to data, it really does place a load on the database. So for MySQL, it's a lot faster to just do a select if it's simple selects with indexes. But with insert, update, deletes, you're not just setting the data, but you also have to update the index. And then indexes are what are used to make your queries go faster. So be careful about when you set triggers. Think about, okay, how much is the load going to increase? Because if you do one insert and then it has to then trigger off another insert statement, okay, you're just essentially doubling the load there, okay, depending on how big these databases are and how many connections are being made. Here's the basic syntax. We always have to name the trigger, and then we specify when does the trigger run. Is it before or after a certain table modification? So these modifications are only related to updates, inserts, or deletes. Then you specify on which table this trigger should run. Okay. So let's say if an update happens on a certain table, then execute all of these trigger statements. Okay. So the table that's mentioned here is the table that if any sort of modifications made to it before an update, before and after, then it will trigger these other statements. And these other statements will then reference other tables. Okay? So you have the option of when you want the trigger to run and for what type of modification and on which specific table. It's good practice to standardize the trigger names because you're also limited on how many triggers you can do for each scenario. Okay? Because you can only have one trigger for, let's say, a before update and then one trigger for a before insert. So it's good to name these triggers. So let's say if we're going to create a trigger on the order details table, if we're going to run an update on it, and we want that trigger to run after the update, we'll name it order details after update. So the format is the table name, when the trigger is going to run, and what is the modification, so data manipulation language. What is that manipulation to the table being made? To go a little bit deeper into the syntax, okay, so before and after is when to fire the trigger. Okay. Using the after is especially helpful when you're auditing because you want it to run uh, to ensure that whatever data manipulation you're running succeeds. Okay. So let's say if you do a change to the table, then run the trigger. For each row, that is included in every trigger, but all it's saying is do it for every row affected by that insert, update, delete. Okay, so if there's a where condition, it will apply to all of those rows matching the where condition. Now we have to use the delimiter command because in this trigger statements area, we're going to be writing SQL statements that end in a semicolon, but we don't want those statements to execute just yet. Okay, so as we're developing our trigger, we have to temporarily reset the delimiter. We could reset it to any character, but in this example, we're going to reset it to a double $sign, so it's clearly distinguishable. So we'll set the delimiter, run our statements, and then, okay, we say we end this entire statement with that new delimiter and then reset the delimiter back to semicolon. So it could be multiple characters, but I use the double $sign because it's very obvious that this is a new delimiter. And then also when you use the delimiter command, make sure to add a space here. Okay. So if you set it to the $sign, you have to do delimiter space $sign. Okay. Make sure there is that space between those characters or character. Another feature of triggers is you can reference what the values were before you did the update, insert, or delete. Okay, because you can reference those to then use for another table. And this is where triggers is helpful. So let's say you're doing an insert on a table and the trigger runs on an insert. Well, you only have the new values available to you because it's a brand new table or a brand new row. So there's obviously no old values, but you can get those new column values and then insert it into another table if you want, or update a table with those new column values. And you would reference it with this syntax. It would be new dot the column name. Similarly, if you're running an update, you want to keep track usually of, okay, what was the old column and then what is the new column. So to reference what was the old column value, it's just old dot and then the column name. And then you could also get the new column value by just new dot column. Okay, so the new dot column is the value after you've made the update. As for delete, because nothing new is being added, you have access to the old dot column value. Generally, you don't want to delete values, especially it's bad for auditing. Auditors don't like that. But if you do need to delete it, you can keep track of what were the old values and then put it into, let's say, some sort of archive table. And you could access those old values with old.column name. I'm going to cover one scenario that we'll use triggers for, and it's an audit logging. Okay. So it's good practice to add these triggers to log any changes to your tables, okay, especially for auditing purposes. But it's also helpful for debugging. So if there's an issue with a certain order or a certain customer profile and you want to figure out, well, what were the values beforehand? You can try to reconcile or do some sort of investigative work, forensic work, by using the data created by triggers. Okay? Or if you want to figure out, well, maybe our data was hacked. What did the data look like beforehand? So we could use this for security purposes. I mean, the alternative is we can keep track of all these changes by doing selects and then putting it into a table, but then that means it's just more application code that we have to write and one more thing to remember. So if we don't want to have to remember these sort of changes that have to be made, if there's some sort of modification or manipulation to the data, we could just add it as a trigger. All right, so what we're going to do is we're going to create a trigger to keep track of changes to a particular column in the order details table. So if there's a change to the quantity ordered, we'll know, okay, what was the value before and after that change. Okay, we're going to create a new table for every time we update the quantity ordered in the order details table. And there's a function in MySQL, and there's similar functions in other databases that give you the user of who's executing the SQL statement. If you're running from an application, that application generally has its own username. So it's helpful to say, okay, it was the application that made a change. Or if a customer service rep was able to make a change, you could see, okay, it was maybe through the customer service rep application. Or was it a data engineer or was it a developer? Again, this helps with the debugging process. And with audits, you have to be able to say who made the change. Here's the schema that you can just copy and paste. All right. So it looks just pretty much like the order details table, but the only difference is we're keeping track of the new and old quantities, and we're also keeping track of when this change happened. So there in the log date. It's a column that's auto set to the current timestamp. Okay, so go ahead and copy and paste that schema. create this table. So if we refresh our workspace, okay, we have the order details log now. Lost my indentation here, but that's okay. So we're going to create a trigger that will fire each time we make a change to this table, to the order details table. All right, so going back to the syntax, you can copy and paste the syntax, and we're going to modify it as needed. All right, so right here we're saying the delimiter should be double dollar signs, so we can use semicolons in our trigger statements. I'm going to say create trigger, and following the standardized way of naming triggers, we're going to say the table name, so order details, when the trigger should run, after a change is made to the order details table, and what is that modification being made? It's an update. So table names order details after update. Say after update. On order details. For each row, that's consistent. Begin and end, that's a block of code. I'll explain that later when we get into stored procedures. And so after an update is made on the order details table, we want to insert into this order details log. So insert into order details log, and you want to specify all of the columns except for log date, because that's going to be set. So you can go ahead and start paste or typing it out. I'm just going to copy and paste it here. Set the values just to make it easier to read. I'll put this on a new line. Okay, so we're going to set the user to the user function. Actually, let's run that. What happens when you just run user? I'll show you what the output looks like. Okay, so it says who's the user, so it's my DBA user and where I'm connecting from. So that's also especially helpful. Okay, is this a known IP address? This is my home IP address. Okay, so insert user, and then it's all of this is going to be the same. We want the old values. So you can copy and paste that, and then type in old, the old prefix for all of them. We want to keep track of it. Okay. That would be old.quantity ordered, because that's the quantity ordered of the order details. And then we want new.quantity ordered. Just going to add some spaces here, make it a little bit easier to read. All right, so that's our trigger. We end it. Okay, so by adding the double dollar sign here, that delimits this entire query. And then we're resetting the delimiter back to a semicolon. Make sure to have this space here. Okay, so let's run this all at once. All right, nothing's happening here. Okay, it's just setting the trigger. So we have to set it off. somehow. So how do we set it off? By running an update on the order details table. We're going to update one specific row in the order details table. Let's go and find one row that we can specifically modify. Going to randomly select one row. Uh, use the order by rand to get that random sample, and I'll limit it to 1. Okay, so we have to look based on these two columns, order number and product number. So our trigger is only dealing with the quantity ordered. We could have easily created a trigger to also keep track of the quoted price, but for simplicity purposes, we're just going to modify one column, and that's what the trigger will look for. All right, so let's say where order number equals 688 and product number equals 25. I'm writing the where statement as a precautionary measure so I don't update the entire table. Update order details, and then we'll update the quantity ordered from 6 to 10. Order details. The whole point of this trigger is to keep an audit log of any changes made to the order details table, specifically on the quantity ordered. We made an update to the order details. We updated the quantity order from 6 to 10. So let's see if that information was logged to the order details table. Because once you run the update, it calls this trigger to insert into the orders details log table. Let's see what's inside the log table. Good, so it shows the user, what my username is, where I'm executing this command from. This is my local domain or IP. This translates into an IP. The order number, product number, and quoted price, those all stay the same. But what we were keeping track of was the quantity ordered, the changes between the before and after the update. So before the update, the quantity ordered was 6. After the update, the new quantity order was 10. And we inserted those values using the old and new prefixes. We also have the log date here, which is handy to keep track of when was this change made. That's good for troubleshooting purposes. So let's also just double check that the values were changed in the table. I'm going to do select star from order details. Using the set of where conditions. So it still shows the quantity ordered is now 10. Let's do another update. Let's copy and paste this same update statement. So we want to run the update so that way it calls that trigger. We'll update it from 10 to, let's say, 21. Ran successfully. Let's see if it inserted into the order details log. Good. So this confirms that the trigger is working. And now we have a historical log of changes made to the quantity order. We can see who made the changes and when. There are a set of commands we can use to manage the triggers to figure out which triggers are in place and for which specific tables. If we want to see all the triggers, we could use the show triggers command. Just going to add a comment here for managing triggers. We did show triggers. Tells me the name of the trigger and the entire statement. It's a little bit hard to see here, but if I copied and pasted this value, it should show what is the trigger statement. Okay. Tells me on what event. Okay, so it's after an update, on for which specific table, and then the timing. It's so the trigger will run after an update is made to the order details table. And we have other columns here that are helpful for debugging. So when was it created to? If we had a lot of triggers, we can look for specific tables based on these columns. We can do show triggers where table, and you have to put table in backticks because it's a reserved word. In backticks, you can find that character under the tilde, so the top left of your keyboard. Tilde is that squiggly line. So let's see the triggers on the order details table. Show that. And if we want to see just the statement to create it, we can do show create trigger and the name of the trigger. Here's the original statement. So it's similar to what the show triggers command displays. And if we want to delete the trigger, we could say drop trigger, but I'm not going to run that. But you can see you have a reference to it in this slide. So make sure after you run all these examples to save the file, you could do Command or Control S. Or if you want to double check, you can do File Save As, and then reselect that SQL file name with your name in it. And that's it. I know a lot of you have been asking for help on the data collection part for the SQL project. So you're starting to realize data collection is not always the easiest task because you always run into limitations, technical, or just simply the data is not available. If you need help with your data collection, please Slack me and then we can work from there. But we can find a solution. Also, if you're planning to web scrape, because of the challenges that many of you are running into, it's okay that you use different tools for web scraping. So if you want to use Parse Hub, if you want to use a Chrome extension, you could use that too to web scrape. Okay. Uh, I know a lot of you are using APIs, which is a little bit more involved. So I'll give extra credit for using APIs. I've yet to determine the exact point value, but I would strongly recommend staying the course with APIs because it is a good skill to learn because most of the data out there isn't APIs. It's not always going to be available even from a web page that you could scrape. Sometimes the data is only behind an API. So I would still strongly recommend staying the course on sticking with your API, even though you could web scrape the data, and that's still a good skill to have. You could show your ingenuity and clever ways of getting data. But both skills are good to have. But if you're staying with API, don't switch over to web scrape just because it may seem easier.